Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. Now here in this question we are given that the position of a particle as a function of time is given by this equation, and there are four parts that we need to solve. In the A part we have to plot the x versus t graph for the time interval t equals to 0 to t equals to 1. Now to plot this equation on a graph, you can use any online graphing calculator. So we have obtained this curve. This is xt graph and the answer for the A part. Now in the B part we have to find the average velocity of the particle from time interval t equals to 0.35 seconds to t equals to 0.45 seconds. Now we know that the average velocity on the xt graph is the slope of the line connecting 2 points between this time interval. Now it would be a little bit tough to find the coordinates. This is 0.35 to 0.45. So we can do another way. We know that the average velocity is delta x over delta t. Now delta t we know it is 0.45 minus 0.35, but we don't know delta x, that is the final position minus the initial position. We can do one thing. We can put the value of t as 0.45 here to find the final position, and then 0.35 here to find the initial position. So let's do it. So 2 multiplied with, now this is 0.45. First we have to put the final position. We have to calculate the final position. So this is 0.45. Then this plus and this minus would become minus. So minus 3 multiplied with t cube. So this would be 0.35 and its cube. So this would be the final position xf, and the unit would be in meters. Now then minus initial position. So for that we have to put t as 0.35 here. So 2 multiplied with 0.35 minus 3 multiplied with, okay, this is 0.45 not 35. I did a mistake here. Then 0.35 and its cube, and the unit would be in meter. Divide by delta t. Delta t we have 0.45 minus 0.35, which is 0.1 second. So we can write 0.1 second. Now we can use our calculator to solve this, and we'll get the average velocity to be equals to 0.55 meter per second. So this would be the answer for the B part, this one. Now next we can solve the C part, where we have to calculate the average velocity for the time interval, this one, 0.39 to 0.41. Same procedure, that average velocity is delta x over delta t, and this would be equals to, now this time the final position would be at t equals to 0.41 seconds. So we can put t as 0.41 here. So 2 times 0.41 plus, sorry, minus, it should be there, minus 3 times 0.41 and its cube. So this is the final position minus the initial position. So for initial position we have to put t as 0.39. So 2 multiplied with 0.39 minus 3 multiplied with 0.39 and its cube, and this is the initial position. Divide by delta t. So delta t we have 0.41 minus 0.39, which is 0.02. So we'll get this answer to be 0.56 meter per second. So this is the average velocity for the given time interval. Now in the D part, final part, we have to find Basically we have to tell that do you expect the instantaneous velocity at time t equals to 0.40 second to be closer to 0.454, 0.56 or 0.58? Now we calculated that in this time interval 0.39 to 0.41 the average velocity is 0.56 meter per second. So at time t equals to 0.40, which is just in between, in the middle of this time interval, 0.40. So the average velocity should be closer to 0.56 meter per second. So this should be the correct answer. So for part D, the instantaneous velocity should be equals to near to 0.56 meter per second. So here in this question we are given that on two different occasions a person accelerates uniformly from rest along on-ramp in order to merge into interstate traffic at 65 miles per hour. Now in the first occasion the ramp is 200 meter and in the second occasion the ramp is 400 meter long. Now in both the cases the initial speed Vi, it is 0 because it starts from rest, and the final velocity becomes 65 miles per hour, and here also the final velocity is 65 miles per hour. Now we have to tell that is the acceleration on ramp A is greater than, less than or equal to the acceleration along the ramp B. So this is the question, basically the A part. Now here we see that in both the cases the initial velocity and the final velocity is same. So we can say that average velocity is same along both on ramps, and therefore you have to accelerate for a shorter period of time along on ramp A, and thus the acceleration must be greater along on ramp A to achieve the same final velocity in a shorter time. Therefore we can say acceleration along on ramp A is greater than the acceleration along on ramp B. Now in the B part we have to choose the best explanation from among the following, and there are 1, 2, 3 options are given. So first option is correct because it says that the shorter acceleration distance on ramp A requires greater acceleration, and this is what we have discussed in part A. Now in the second part it says in each case you start from rest and have same final speed. So it is not the correct reason that why this acceleration is greater than the acceleration on ramp B. So this is wrong. The greater distance traveled on ramp B requires greater acceleration. This is completely wrong. So option first is correct. So here in this question we are given that a runner accelerates at 1.9 meter per second squared for 5.2 seconds. So I've shown this thing in image that at time t equals to 0 he begins to run, and for time t equals to 5.2 seconds he accelerates with 1.9 meter per second squared. So let me show it here. For this time interval the acceleration is constant, which is equals to 1.9 meter per second squared. Now the runner's acceleration is 0 for the rest of the race. So after 5.2 seconds the acceleration becomes 0. Acceleration becomes 0, it doesn't mean that velocity becomes 0 or the speed becomes 0. Now there are two parts that we need to solve. In the A part we have to find the runner's speed at time t equals to 2 seconds. Now since acceleration is constant, so we can use the equation that we derived under the topic motion with constant acceleration. So for this situation we can use this equation that we derived, v equals to v naught plus at. Now v naught is the initial velocity, which is 0 at time t equals to 0, the velocity is 0. So this is 0 plus, now acceleration we have 1.9 meter per second squared. So this is 1.9 meter per second squared multiplied with t. Now t is 2 seconds here for A part, so 2 seconds. Now from here we'll get the velocity to be equals to 3.8 meter per second. So this would be the answer for the A part. Now next we have to find the speed at the end of the race. Now since at this point, at this time, the acceleration becomes 0, that means after this interval, after this instant, the speed would be constant because the acceleration is 0. Now if you find the velocity or speed at this interval, then that would be the same speed he would be running at the end of the race. That's the concept we can use here. So B part we can solve now. So same equation we can use, V equals to, now V naught is the initial velocity, which is 0, plus acceleration for this much time period is 1.9 meter per second squared, multiplied with time is 5.2 seconds. Now you can solve this and we'll get the answer to be 9.9 meter per second. So this is the answer. So here in this question we are given that a car is traveling in the north direction at speed 23.6 meter per second. Now we have to find the velocity of the car after 7.1 seconds. And there are two parts. In the A part they are saying that the acceleration is 1.30 meter per second squared due north. So let me show it on the figure. Velocity is also in this direction, which is 23.6 meter per second, and acceleration is also in this direction due north, which is 1.30 meter per second squared. Now we have to find the velocity after 7.10 seconds. Now since the acceleration is constant, so we can use those equations that we derived in the topic motion with constant acceleration. So for this case we can use this equation, V is equals to V naught plus AT. Now initial velocity is 23.6 meter per second, and since acceleration is also in the same direction, so we have to take a positive sign because we have taken this direction to be positive. So plus acceleration is 1.30 meter per second squared, multiplied with time is 7.10 seconds. Now we can solve this by using our calculator and we'll get the answer to be 32.8 meter per second. And what would be the direction? North direction. So this is the answer for the A part. Now you can solve the B part, where they are saying that the acceleration is 1.15 meter per second squared due south. That means in the B part the acceleration is like this, in the opposite direction to the velocity. This is velocity. Now acceleration is 1.15 meter per second squared. Now for the second case we're going to use the same equation, this one. V is equals to V naught plus AT. Now initial velocity is same, that is 23.6 meter per second, plus, now this time acceleration is opposite to our positive direction, so we have to take a negative sign here. So minus 1.15 multiplied with T is 7.10. So we can solve this by using our calculator and we'll get the answer to be 15.4 meter per second. Now since the velocity comes out to be as positive, that means the direction of the car would be in north direction. It would be moving in the north direction. So we can write here north.